So take it away.
Thank you, Dr. Morgan. That was most of my talk, so hopefully the rest is pretty straightforward. I'm excited to talk to you today about some of my PhD work investigating drivers of no-till adoption. So, once I can figure this out, and we're recording, is that right, Dr. Smith?
If you just click on that. No.
Still, computers are not the, we got the Fortran story earlier, not so much has changed, actually.
All right,
okay, let's try it.
You want to do this one?
Okay, back. All right, excellent. Now we're running.
Okay.
So Dr. Morgan mentioned the concept of soil security. In 2016, the College of Agriculture and Life Science here at Texas A&M put some seed funding into the concept of soil security, which is the idea that we need to deal with soil challenges to address other global existential crises like energy security, water security. We've got energy sustainability, human health, biodiversity protection, and climate change. And each of these issues has soil as a part of those challenges. We want to approach these issues holistically. There are 5 dimensions of soil security. The first is the soil's capability. We're interested there in the static biophysical properties. We might think of something like texture. It's really difficult to change, but we need to understand it. And the second dimension is condition. This is the soil health dimension, the manageable attributes of our soils that we need to understand. And in terms of capability and condition, in our project we have Dr. Morgan and Dr. Serini Ali in agricultural engineering working in those areas. We're also interested in soil capital. This is the economic dimension. So this includes both market economics, issues around yield and cost and risk, as well as emerging markets, ecosystem services, and Rich Woodward in agricultural economics is championing that portion of our work. The fourth dimension is connectivity. So these are social issues connected to soil science. What do people know about soil? How much do people care about soil? What would they be willing to do to conserve it? And the fifth dimension is codification. I should note that Alex McIntosh and a PhD student in sociology are working with us in the connectivity dimension, and as a team, we hope to inform that fifth policy codification dimension. So from that seed funding, we were able to land a NIFA USDA grant, and as our team began that work, we began to focus on the Blackland prairies, which you see displayed here in purple in this ecoregion map. And I've just penciled in blue the Brazos River, which you see intersecting that purple area right there. And our folks in sociology and econ, and they kind of didn't believe us. They know soil scientists care about soils, but they did a really good job of tapping into other stakeholders. So the first issue that came up was sedimentation as a concern. Lake Granger, for example, capacity is filling up quicker than they had anticipated, the Brazos River Authority says. Also concerns about both endangered and sports fish species in the river. Other than sedimentation, nutrients and pesticides were something that is on their radar. They're interested in these issues. There's stuff about this in the news. And then finally, flooding is certainly a concern for those of us in this region. We think to flooding events that can do a lot of damage to crops and to other investments as well as human lives. So each one of these bullet points in this region is tied back to the idea of rainfall partitioning. So when water strikes the ground in a rainfall event, is it going to infiltrate into our soils, or is it going to run off, and in what proportion? And in this high shrink swell area, we do have cracks that can open and receive a lot of that water, but the soil matrix itself has low hydraulic conductivity, so infiltration is going to be slow. In that issue of rainfall partitioning, the other player is soil structure. Some of you may be really familiar with soil structure, others a little bit less so, but these are pictures that conceptualize different soil structures. And we would prefer in our fields that we manage to have something like a granular or blocky structure that allows water to move around our PEDs and infiltrate faster than it would if we're just looking at the hydraulic conductivity of the matrix compared to something like a massive structure, and we're really limited by just that high clay content slow infiltration. And one of the reasons that soil structure is so important is not just because of this impact, but because we believe that we can manage it, whereas soil texture, you really can't. In fact, it's important enough that soil scientists have tried to create models to understand mathematically how water moves in between PEDs and infiltrates into a soil. So So what are our options when we think about managing soil structure in our fields? Here are 3 examples of options. Over here closest to me, I've got a conventionally tilled corn in our Blacklands prairie. This is tilled at least once a year. That breaks up the soil structural units within the area that we're tilling. We have a no-till system in the center here. This is a 21-year no-till, also in the region. And then we've got a perennial system. So we would conceptualize that our aggregate stability and our structure is going to be best in our perennial system, where we have a lot of residue on the ground, we have roots growing. We hope that our no-till is mimicking that and providing better soil structure, and we'd imagine that the worst is right here in our conventionally tilled system. So as soil scientists talked about these management options, the rest of our team wanted to know, well, how are folks doing this? Does this seem like a good thing to do? And the data says that, and this is NASS data, that very few farmers are adopting no-till in Texas. So here we have Texas corn in 2007, about 6% adoption, and in 2010, cotton had about 8% adoption of no-till. So there's a disconnect between what we think would be a good management system as soil scientists and what people are actually doing. And as we chewed on this data, this information as a team, 2 research questions kind of came to the front, and that's what I'm going to talk to you about today. The first question is, are we crazy? Is no-till even changing these soil properties? Let's go out, let's get into farmers' fields with a field study and measure the properties and see whether or not no-till is having an effect. The second question goes back to, can we shift those pie charts at all? What are the drivers of no-till adoption? And the way that we have hoped to get at that is by developing a model which terms include the different drivers of no-till adoption, and to test that in a survey. Now, I have data to show you from the field study today. Our survey is under development. We have the first full draft this week, so I won't be showing you data from that question, but we will look at the model and discuss it. So thinking now to that field study and digging in a little deeper, it is an observational study. So we're in farmers' fields. We have 8 perennial, 7 no-till, and 7 conventional fields located in 3 counties, Falls, Williamson, and Milam counties. This is observational, as I said, so there's a range in the no-till. I've got a 3-year field, a 7-year field, one that's 18, and then 4 at that upper 21-year-old range. And our perennial systems are 50 years to 100 years of age. These are high shrink swell soils, so they're fine smectitic and thermic. Mostly we had haplostarts. We've got a paleostall and a haplostall in there as well. And we wanted to note that the pH was pretty stable, 7.5 to 8.1%, with greater than 95% base saturation. And I note that now because we hope that that's not the driving factor in the changes that we're going to see in a moment. So in the next slide, we'll talk about the 5 measurements that we'll see data from today. The first is organic carbon. We're looking at organic carbon in a soil pit within each one of our fields. We looked at 2 depths. The first was 0 to 10 centimeters, and the second was 10 to 30 centimeters deep. We took bulk density cores, 3 that were surrounding that pit, and we looked to 15 centimeters depth. In retrospect, we really should have gone deeper. You'll see why very shortly. Saturated hydraulic conductivity was done with constant head infiltrometers, single ring, and 3 of those rings. We also looked at aggregate stability, or we actually look at flaking, which is the inverse of aggregate stability. So we're using a Flakes app. What you see in this picture down here is an Android phone just sitting above a Petri dish with 3 little soil aggregates in it. The red outline that you see is just the area, and as it expands over time, we'll see how that changes. We'll get a flaking index for each aggregate and then each Petri dish. Undergraduate student worker Kay Flynn will present next week more on this technique, so I will spare you the details and not steal Kay's thunder. But we're really excited about it, and I'll show you some data from it. And then the 5th thing that we will look at data from is multi-stripe laser triangulation, or 3D soil structure scanning. For those of you who remember Sarah Vaughn and her work, this is the technique that she was working on. This is a little portable desktop 3D scanner that you can just sit in a pit and measure the surface of that soil with, get a surface from it. And I'm now going to transition to talking in more detail about that analysis because it's kind of unique and pretty interesting. So what you see now, closest to me, is a soil pit. It's 50 centimeters wide, and it's 30 centimeters deep. We put that little scanner in there, we get a surface, and then it's an XYZ file that we can bring into our studio. And the next thing we have over here is what we've done in our studio. So on the y-axis, we have depth in millimeters. On the x-axis, we have pit width in millimeters. And our elevation is in millimeters from white to green, 0 to 50 millimeters, projecting out towards us. And now we've got a lot of dots running around on that surface. So we use a moving window to find local minima and maxima on that 3D surface, and that's what we've plotted in those dots. Our next step is to draw Dirichlet tessellation polygons, which sounds really scary, but all we're doing is assigning the area in one of those little black polygons as being closest to a particular point that's within that polygon. Now, we don't think that these little features, these black outlined features, are soil PEDs that we can go and find in the field and take back to the lab with us, but we do think this is a good way to characterize the soil pit surface. And so our next slide will talk more about that. What you see here, again, is depth on the y-axis and pit width on the x-axis. We've got two different fields. One is conventionally tilled, and one is a perennial grass. And now we're just looking at those Dirichlet tessellation features. So we can notice that there are size differences, but what we have found that to be the most stable indicator of changes is the variation of the feature size within a given pit. So when we do a log transformation, because these are log normal feature areas, and then we look at the standard deviation, what we find is that conventional pits have some really big features, and they have some small features, whereas perennial fields tend to have more well-ordered, similarly sized Dirichlet tessellation features. And so we now have that metric that I mentioned, that standard deviation of the natural log on the y-axis, and a box plot with yellow conventional till, no-till in red or maroon, and perennial in gray there. The rankings that you see, we ran an ANOVA for both texture and tillage, and we had significance, so we went on with a Tukey's HSD, and we have conventional till statistically significantly different from both no-till and perennial. What's interesting about that is that if we think back to our first research question of, is no-till making a difference? According to this metric of soil structure, yes, no-till is shifting our system to be more well-ordered in those features and to look more like a perennial system. I mentioned that we looked at soil texture. Texture was also significant, and what we found was that we had a clay, a silty clay, and a clay loam. Clay and silty clay were not different from one another. Both were different from the clay loam. So that's telling us it's probably soil, it's probably clay content rather than soil texture per se that is driving this, but it's something to note. So that's kind of good news for us and our first bit of data there, but the next slide will look at the other four pieces that I had mentioned. Over closest to me on the top, we have organic carbon. It's 0 to 10 centimeters, that top range that we're looking at first. And again, we've got a significant ANOVA. We followed up with Tukey's HSD that will continue throughout the rest of these box plots. We have conventional till and no-till not statistically significantly different from one another. Now, I'd argue that they might be practically different in terms of organic carbon in these generally low organic carbon systems. We do see that perennial is different, so that's pretty good news. If we were to look deeper at the 10 to 30 centimeter depth, we would see no change. So the action in terms of organic carbon is happening pretty much in those top 10 centimeters. When we move on to saturated hydraulic conductivity, we again have the same ranking. Conventional and no-till are not statistically significantly different, but perennial is. Now, whether or not there are meaningful differences in KSAT and infiltration in our no-till and conventional fields is a bit of an open question, even though the statistics show that they're not significant. Seyantan is here, and he and Dr. Ali will be working on some longer-term modeling to see how the infiltration over longer periods of time will change and whether or not we're capturing more rainfall to an important level. I mentioned that we should have gone deeper with our bulk density. We don't see statistical significance even in the ANOVA at this 15 centimeter depth. Probably if we had gone deeper, we might have seen something. But I'd just like to note that if this data is true to depth, then it's actually not a bad thing, Because we have a narrative among these farmers, well, I can't go to no-till because I have to till, because otherwise the compaction will be unmanageable. And so not statistically significant difference between no-till and conventional might actually be a favorable result. And last, you've probably beat me to the ranks on the slaking index. Recall that slaking index is inversely proportional to aggregate stability. So the yellow box plot, which is conventional, has the highest slaking index and the lowest aggregate stability. And we were able to statistically differentiate between conventional, no-till, and perennial. So we'll park here on this data and just think back to our first question, which was, are properties changing in farmers' fields? Our soil structure and our slaking index say yes, no-till and conventional tillage are different from one another. We have statistical differences. What we don't know is whether or not we have meaningful differences yet in terms of infiltration and organic carbon, which are certainly things that we care a lot about. So some modeling work should inform us more about whether or not these changes are meaningful off-site. But are these changes meaningful to farmers? Along that line, let's switch over to our second question, which is how can we affect this no-till adoption decision? So our first effort in trying to answer this question was to form focus group interviews. So we had about 7 to 8 farmers who were using no-till, and then 7 to 8 who weren't separately. We talked to them for about 3 hours and asked them a series of questions to try and understand the different things that they were considering when they were choosing these tillage practices. That allowed us to develop a model that we believe has all the different factors that they're considering in it. And we'll walk through that model now. Pardon me. This will be a linear model, and there are 6 terms within it. The first term is the utility, or the value that that farmer perceives from profit considerations. So this is pretty straightforward. Is it going to reduce my cost? Is it going to increase my cost? What will it do to my yield? Will it change the risk of being able to make a yield in a bad year? The second term is the utility from non-pecuniary sources. So that's econ jargon for stuff that kind of makes you feel good. So does my dad really think I should go to no-till? Or maybe my neighbor's going to laugh at me if I go to no-till. Those are the issues that fall into that second category. The third is the utility from government assistance when that exists to change to no-till, to transition to no-till. The fourth is the perception of management, that's tillage practice, on access to a parcel. So we heard this quite a few times in our focus groups. You know, I'd be interested in going to no-till, but my landlord wants it to look like it always has. They're not interested in trying something new, and I'm not going to go to a practice that they don't like because then I may not be able to rent this land in the future. The fifth is kind of the plots we were working on a minute ago, saying, do farmers value these soil attributes? Do they think organic carbon is important? Does it matter to them? Do they think infiltration is important? Maybe they're just focused on yield. Those are some of the questions that we'll be trying to get at to evaluate that fifth term. And then sixth, the perception of how my management, that is no-till, is going to change those soil attributes in number 5. So maybe I think organic carbon is really important, but I do not think no-till is going to change it. Well, then I won't adopt it anyway. So those are the terms that we'll be evaluating. Our survey instrument is under development right now, and what we want to do is see whether or not some of those issues, some of those terms drop out, and we also want to weight them. We may find that there are, in this particular area, we'll go out to farmers in the Brazos River region, in the Blackland Prairies, and so we're interested in being able to say what they particularly are motivated by, or maybe that they're not motivated by. And the whole point of all of that work is to try and to answer this question, if I want to go back and change that pie chart, what should I be working on? What is most important, and then maybe what's easiest to change. So again, we don't have data yet, but this is exciting work, and I'm really happy to be part of it. With that, we've kind of touched on both of our research questions, so I'll summarize and mention what we're working on in the future. So if we think back to our box plots, we were able to use the soil structure indicator and the slaking index to say, yes, we do think that no-till is changing relative to conventional till. When we look at saturated hydraulic conductivity and organic carbon, we do not see statistically significant differences between no-till and conventional. That could be because these are just really hard properties to change. But the next question is, are those changes meaningful for off-site services, ecosystem services. We think way back to the map, the things people are worried about. Does the infiltration change or the KSAT change that we measured make a difference to those people? And so we hope to expand our field work to other soil textures in the future. We are also interested in doing that modeling of the on-farm ecosystem services. Do I capture enough water to maybe make a crop this year? Do I reduce my runoff enough to change the sedimentation in Lake Granger? And then lastly, we want to test those coefficients, those different terms, by asking questions that get at what our farmers are interested in. With that, I've got a lot of people to thank and acknowledge. Our funding sources, my committee, our hydropedology group, our soil security team. It's been a pleasure to work with. I spent the summer working on the soil structure issue with the University of Sydney in Australia, which was fantastic. And to all of you in the Department of Soil and Crop Science, which I've been in probably far too long, I thank you for your continued support of my career and of me as a person. So with that, I will park on these references and ask for questions. Yes, sir.
At what stage of growth did you take your samples from the conventional and the no-till system versus were they taken all at the same time of year, and at what stage, like how big were the plants when you took them?
Yeah. We did not pay attention to growth stage per se, but in terms of time of year, we were looking at early spring, and that was mostly because we are in these shrink swell clays, so we had to work when those cracks were not open, or our soil structure would have been wild. So happy to look into that in more detail, but I think they're pretty similarly timed in time of year. Greg?
The survey, is it focused on a single crop, or is it multiple crops, or what's the idea there?
Right, so the question was, is the survey going to focus on a single crop or multiple crops? We will ask the farmers to provide some information about what they're growing. We're certainly open to different crops. We didn't want to control for that, or to limit that. Dr. Haig?
When people are trying to make a decision to switch to no-till, the issue of weed control should come up. And obviously we've got problems with herbicide resistance. Did that factor into people's decision-making process that you picked up on?
I did not often hear weed control singled out, but certainly I think the idea that tillage is more than just a planting mechanism, but it provides a lot of other services that we use, is probably important. What I heard mostly come up was moisture management in the spring, and whether or not there was so much residue that they could get in and plant. And not disturbing that soil kind of limits their ability. So I didn't hear it singled out specifically often, if I think back. But I think it's part of the picture when people say it's more complicated to go to no-till. I have more things to manage. I would say yes. Yes, sir.
Have any of the folks that you visited with, have they reverted back from no-till?
So the question was, has anyone that I have visited with reverted back to no-till? We talked to people who were using no-till on some plots and not others, and they thought it was good for some pieces of land and not others. I don't know that I heard anyone say, I went to no-till and I do zero now. But I also had folks who were kind of dabbling in it. So I do it over here, I do it on my land, I do it away from the county roads, no one can see it. Or I do it and then sometimes I till it because for various management reasons. And then I did have someone with strip till who is continuing to experiment with that and considering whether or not to expand it. Dr. Neely.
On your no-till data, did you look at it and kind of pull it apart to see if there were any trends with the fields that have been in no-till longer versus ones that have only been in for 3 or 5 years?
The question was whether or not we saw age of no-till as being important. I remember in detail looking at that for our structure stuff, and the answer is no. It didn't seem to be a huge issue, which is not what we like to see, but I think that's just the lack of precision in that method. I don't have an answer right off the top of my head. Dr. Baldensberger.
So how many were you able to get to complete the surveys?
The survey's not gone out yet. We had 16 participants in our focus groups. But hopefully we'll get 400 or 500 folks in the survey. That would be our goal. Yes, sir.
The pie chart that you showed, is it from Texas or from the whole USA or from the whole global scale?
It's from Texas, the pie chart.
So compared to other states, which states has the highest non-till percentage adoption?
I'm getting fed answers from the front, I have to confess. Tennessee is what an educated guess is. I do think that we have lower adoption rates than other places. I think that in part is due to the nutrient soils are difficult to manage. I think there are other issues there as well. Brian?
How do you choose who goes into a survey?
Well, hopefully it's randomly sampled or we get really bad data. The question was how do we choose who goes into the survey? So we're at this point attempting to run it through NAS. So we would provide questions to them. They would mail it to a list of people who say, I farm, and their addresses are in this region. And then they would self-select for, they would list whether or not they no-till or conventional till, or they will define that. Marie, did you have a question?
And NAS is?
The National, I don't know. Ag Statistics, there you go. Hard questions are coming out. Any other acronyms that I can provide? You can make them up.
With that, I think it's actually time.
Excellent.
Thank you so much.